In this video, we're going to go through part 2 of section 5.1, focusing on angle measures. And we're going to learn a new format for measuring angles. Instead of using degrees, we're now going to introduce a new concept, a new type of measurement called radians. We're also going to focus on some more circular motion concepts in this section. In part 1, we focused on building an angle by joining two rays at a vertex. We kind of started at the origin. My thumb can represent kind of the initial side of our angle, starting at the origin at the base of my thumb. And then we built a terminal side, represented here by my index finger, that terminated somewhere. And that little, my webbing, so to speak, represented the angle, and we measured it in degrees. Well, we're going to do that same concept, but we're going to change things up a little bit. We're going to do it within the context of being on a circle. That circle is going to have a radius r, and here's what we're going to do. Our initial side, again, is going to start at the origin, but now it's going to be a segment. It's going to terminate right on the circle, right at the, we'll call it the eastern pole if we want to. But in any case, we're going to stop right on that red dot. We're then going to travel along the circle, and I'm going to call this distance that we travel, it's highlighted here in green, I'm going to give that a value s, and I'm going to call that an arc. And where I decide to finish my arc somewhere again along the circle, I'm going to connect my terminal side. So terminal side again, I still have built an angle, but I've done it in a slightly different fashion than what we saw before. So bottom line, here's what we've done. Each segment has a length of r, the radius of the circle. The length of the circular arc, we are going to give the value s. Again, it's this trip. How long did we travel along the circle? Angle theta, the thing that we built by traveling along this arc, is called a central angle. And finally, we're going to say that this angle has been subtended. And as an acronym, or a synonym, excuse me, for subtended, we can say created or made. But the book term that you'll see is subtend. We're going to say that this angle theta has been subtended by traveling along this arc. We can also say, if we want to, that this concept is going to lead us into a comparison of the ratio of our arc travel, how far that or how big that value of s is, and the value of the radius is. So this is going to now lead us to the following. We're going to do a ratio. We're going to calculate the ratio between our sector length, how long we travel, or our arc length, excuse me, arc length, and the radius of our circle. And that ratio, s divided by r, is going to be what we're going to use to measure angle theta. And the form that we'll have this in, we will say that this measure will be measured in radians. So, angle theta is going to be measured, as we say again, in radians. And radians are going to measure the ratio between arc length and the radius value r. And there's our formula. Our angle measure in radians is equal to s sector length divided by the radius. So let's do something very simple. If s equals r, well, the ratio is going to be 1. And so the bottom line, a central angle, when it's created by an arc that is the same length as its radius, that angle will be measured as 1 radian. And we'll do something real quick here because this will be helpful for us as we move forward. How many radians are there in one complete circular revolution? Okay, well, if we traveled all the way around the circle, what would we have done? We would have traveled along the circumference. How big is the circumference of a circle? That's equal to 2 pi r. And in this case, that would be our value of s. What's our arc length? Going all the way around the circle, 2 pi r. What's the ratio of arc length against the radius? It's nothing more than s over r in this case would be 2 pi r over r equals 2 pi. So what we find is, and this will help us, when we travel around a circle, we create a central angle of 2 pi radians. That's going to be very helpful to us. So a angle created by going all the way around the circle is 2 pi radians. So, if a full revolution is 2 pi radians, half a revolution is nothing more than what? 1/2 of 2 pi r over r. It'd be nothing more than 1/2 of 2 pi. 1/2 revolution is pi radians. A quarter revolution would be what? 2 pi over 4, or pi over 2. And 1/6 of a revolution, well, how long would our sector length be? It'd be just 2 pi over 6, our arc length, excuse me, arc length. 2 pi over 6, which is nothing more than pi over 3. So we have some very simple ways now to measure radians. We use kind of concept of half revolutions. Let's do something that would be very useful. We now have 2 ways to measure angles, degrees, and radians. Let's find some equivalencies. 2 pi radians, we said, was a complete trip around the circle. It's 360 degrees. A semicircle would be what? Pi radians. We just saw that above, half a revolution. We knew that half a revolution was what? 360 divided by 2. Pi over 2, we said, represented what? 1/4 of a revolution. What's 1/4 of 360? It's 90 degrees. And we can keep working the same way. We can use some of the relationships we already have to solve some of these others. If pi radians is 180 degrees, pi over 3 radians ought to be 180 divided by 3, or 60 degrees. Pi over 4, I can take 180 divided by 4, I get 45 degrees. Pi over 6, take 180 divided by 6, 30 degrees. So these are kind of useful, but here's the bottom line. A very simple conversion factor. Just note the following. 1 radian is equal to 180 divided by pi degrees. Right here you can kind of see it. Pi radians equals 180. Well, pi over pi would give me what? 1 radian. And that would have to equal what? 180 degrees over pi. And similarly, working in the opposite direction. 1 degree equals pi over 180. Again, hey, just take both of these. 180 degrees divided by 180 degrees. That gives me the 1 degree. I'd have to do the same thing over here. Pi over 180 radians. And so with these conversion factors, I'm in very good position. 50 degrees. Well, what do? Well, 1 degree is pi over 80. 50 degrees must be 50 pi over 180 radians, which would become 5/18 pi. Negative pi over 9, what can I do? Well, I'll take negative pi over 9, multiply it by 180 over pi. Pi's cancel out, the negative sign doesn't. I'll have negative 180 over 9 equals negative 20 degrees. 5 pi over 6 degrees, that's in radians. 5 pi over 6 times 180 over pi. Pi's cancel out. 5 times 180 we'll find out is 900 over 6. 900 divided by 6 gives me 150 degrees. And that's not necessarily too surprising. Think about it. 5 pi over 6 happens to be what? A little bit short of pi, a little bit less than 180 degrees, and 150. 5/6 of 180 is exactly what we saw here. 160 degrees convert to radians. What's my conversion factor? Multiply by pi over 180. What will I have? Well, I'll have 160 over 180 pi, 16 over 18. I can keep reducing that even further. So let's just watch. I'll do it bit by bit. 16 over 18 times pi. Divide one more time by 2. 8/9 pi. 160 degrees is the same as 8/9 pi radians. So, in radians, we'll also have a concept of coterminal. I can rotate multiple times around a circle if I'm so inclined. Each revolution, well, 360 degrees is the equivalent of 2 pi. So, if we have an angle measured in radians and we're asked to find coterminals, in radians, our plus or minus factor, what we add by, is the equivalent of 360 degrees, namely 2 pi radians. Who's coterminal with pi over 4? Pi over 4 plus 2 pi. If I work with this, 2 pi is the same as, from a fraction standpoint, 8 pi over 4. pi over 4 plus 8 pi over 4 equals 9 pi over 4. Pi over 4 minus 2 pi, again, let's use our 8 pi over 4 as a representation, get a common denominator, negative 7 pi over 4. So remember, coterminal, radians plus or minus 2 pi. Find two angles, one positive and one negative, that are coterminal with negative 2 pi over 3. 2 pi, just so we have it, is the same as, in this case, I want over thirds, is going to be the same as 6 pi over 3. Let's find our positive angle, negative 2 pi over 3 plus 6 pi over 3, sorry for my handwriting here, is going to give us what? Positive 4 pi over 3. Negative 2 pi over 3 minus 2 pi minus 6 pi over 3 gives me negative 8 pi over 3. So far what we've seen the radians measure. It's the ratio of arc length divided by radius of our circle. That's what radians represent. We've seen that a full trip around a circle is equivalent to 2 pi radians. And we have the ability now to work back and forth. We can convert a degree measure to a radian measure pretty handily.